All right, so we've talked about area, and that's dealing with two-dimensional figures. So let's move on to three-dimensional figures. This is just going to be an introduction to three-dimensional figures, but we'll move along further with it next week. But the primary set of three-dimensional figures we're going to work with are called polyhedra. Polyhedra is the plural of the word polyhedron. A polyhedron is a 3D figure. 3D, of course, means three-dimensional. And it's composed of polygon faces that share, oops, wrong there. Just in case an English teacher clicks on this video, that shares their vertices and sides. A polyhedron is always a closed figure, just like a polygon is always a closed figure. Polyhedron just takes up more three-dimensional space. And it's all polygon sides. One of the most common polyhedron that we know is a cube, or a rectangular prism. We'll go further in depth on what prisms are, but I hope at this point in your life you guys know what a cube is. So a cube, if you were looking at a cube, that's what you would see. These are the visible faces. And these polygons are the faces. Where two polygons meet in a polyhedron, that segment is called an edge. And where two edges meet, that point is a vertex. So for a cube, we have 6 square faces, and all of the edges are the same length. There's 12 of them. And the vertices are just points. There's 8 of them. Now, this is what you would physically see. Most of the time when we draw a representation of a polyhedron, we also include the edges that we wouldn't see. But since we don't see them, we draw them as dashed segments. So these would be the 3 hidden edges. That'll be a good name for a young adult novel series. Just saying, if you do end up writing that, credit me. But we have edges, and there's edges that you wouldn't see. Those are just hidden edges. We represent them with dashed lines because we wouldn't physically see them, but they do exist. By drawing in those hidden edges, it gives us a better encapsulation of what the whole figure is, not just what we can see, like what's happening behind. So we've got faces, we've got edges, we've got vertices, and then we've got the hidden edges. So oftentimes we'll represent it like that. I'm just going to quickly redraw that cube. I know this version isn't as neat as the other one was. I just really rushed through it. So let's say we have that cube. Imagine that's not garbage representation. So that's one representation. This is the 3-dimensional representation on a 2-dimensional plane. Another way to represent a cube on a 2-dimensional plane is to lay out all of the faces on the 2D plane. So it's like cutting apart that cube and laying it out so we can fold it up. Doing that is called a net. A net is a 2-dimensional representation of all the faces in a 3-dimensional figure. So this one it's 6 squares. 6 squares make up the cube, so our net is going to be 6 squares. So we have 1, 2, 3, and 4. Now, if we were to cut these out, we could fold up 90-degree angles from each of them, and that would just give us 4 of the faces of the cube. But then there'd be 2 gaps on the side. So we could draw in those extra 2 there. If we were to cut this out, we could fold up, fold up, fold up those, and this would flap over to the top, creating that square. I'm sorry, creating that cube. So this is a net. It's another way to represent it, and it helps us understand all the surfaces that create that polyhedron. Now, polyhedron don't have to have just squares or rectangles. Think about Egypt. And when you think about Egypt, what you probably think about is Africa, and then the Nile River, and then pyramids. I'm just kidding. I don't know what you think about when you think of Egypt. Honestly, the first thing I think about is pyramids. And also Brendan Fraser, because of those mummy movies. But if we had a pyramid, like the Pyramid of Giza, the Great Pyramid has a square base and then 4 triangular faces all meeting up at a point. So if we want to do a net, it's 1 square, oops, and 4 triangles. So we have a square, and then a triangle off of each square. And these triangles will fold up. These 2 pieces would match together. These 2 would match together. These 2 would match together. And these 2 would match together. And all these 4 points would meet at that vertex up there. So this is the net of a square pyramid, like the Pyramid of Giza. And we'll talk more about pyramids later. Now, what nets are going to be primarily helping us with is finding the surface area. When I say the surface area, what that means, it's the total area of all the faces or surfaces of the three-dimensional figure. So the surface area of this, how we would find is we'd find the area of the square and then find the area of the 4 triangles and add them all together. And that would give us the total surface area. The other measurement you can find out about three-dimensional figures is volume. Volume is how loud it is. I'm obviously just kidding. Volume is the amount of space the three-dimensional figure occupies. All right. So area, we had done a whole chapter of it, is on the two-dimensional plane. So we've got length by length in 2 dimensions. So area and surface area is measured in units squared, but volume, it's 3-dimensional space. So we've got length, length, and then a third dimension. So we've got the length and length, and then we've got the length coming out straight at us. So we've got 3 dimensions, so it's units cubed. All right. That's about it for the introduction of 3-dimensional figures. We'll talk more and we'll introduce more types of 3-dimensional figures beyond polyhedrons soon. Talk about finding their volumes and surface areas of specific figures next week. All right, have fun.